You are watching the 8.8 lesson video on comparing functions. Looking at question number 1, we need to graph two functions, f of x and g of x, over the domain. So let's not forget about this piece here because that's pretty important. A lot of people just want to throw arrows on the ends of functions, and in this case we will not do that. We have two close points. Then it says answer the following questions below. All right, well, let's get to it. Number 1's f of x function is a quadratic, so we're going to use our technology to help us graph this. And in order to support our graph, we need a table of values. But let's be smart about this. We only have to graph it over the domain. We don't really have much space here, do we? All right, I'm just going to try squeezing it in right here. X and f of x. You can do yours off to the side on your paper if it's easier. I probably should do that or whatever. That's all right. So we need to graph it over the domain from -1 all the way to 4. So -1, 0, 1, 2, 3, 4. Okay, so -1 is 8, and I'm just using my calculator. 3, 0, -1, 0. Oop, I found the vertex at 2, -1, and then 4, 3. Let's go ahead and graph those values. So we have a pretty graph. Connect the points, and my two endpoints are closed because of my inequality symbol, less than or equal to. I also am just going to label this piece f of x, just so I don't get the two functions confused. Okay, let's also graph g of x, which is a line. This is a lot easier to show work. There's our y-intercept, and our slope is 1 over 1, so up 1 to the right 1 where we start at 3. And remember, we are only graphing this over the same domain, so I'm going to stop where my line, so I could continue graphing and plotting all these points. We've done this before, cover the whole graph, but then realize, oh, wait a minute, we're only graphing this over the domain from -1 to 4, so I don't need any of those points. And I don't need, let's see, any of those points. But what I do need to do is connect my points with a straight edge and label it g of x. Okay, so now I have my two pieces, actually my two functions. And in part A, it says, what is greater, f of 4 or g of 4? Well, why don't we figure out what each of those are? So f of 4 and g of 4. So f of 4, well, f of 4, here's my f of x function, the function that's written in my black line, is 3. G of 4, on the other hand, is 7. So remember, f of 4 means what is y when x is 4. So which is greater, f of 4? Well, we're comparing 3 and 7, so g of 4 is greater because it's at 7. Okay, which is greater? Let's do the same thing here, except we're now just trying to figure out two different x values, f of -1 and g of +2. So f of -1 is 8, and g of 2 would be 5. So which is greater? F of -1, because 8 is greater than 5. Then for part C, it says, for what value of x does f of x equal g of x? Okay, we've seen questions like this before. So what does it mean, f of x to equal g of x? It's where they intersect. So where do they intersect? They intersect at the point, that didn't want to layer the points. It's at that point it keeps disappearing. The y-intercept, and that's the only place, which is 0, 3. So here it's saying for what value of x, we only care about the x value of the point, so only when x is equal to 0. Remember, it is not the answer 0, 3. That point is not the solution. All right, cool, let's move on. Number 2. Looks like we got a graph x squared and 2 to the x on the same graph. So I think table of value time is important, so I'm going to add a new page, add a graph. You know what, go ahead and pause the video because you have your calculators, and I want you to graph these two functions just on the calculator. Okay, so here's what mine look like. I'm not a huge fan of this because, first of all, these are overlapping, so I'm going to maybe click and drag so they're not on top of each other at least. And look at my window compared to the window that they gave me. Well, why are they doing this? Well, they only want all of the values, the domain, when x is bigger than 0. So we don't care about any of my negatives of my x's. So I could get rid of all of those negatives, and it looks like it doesn't even matter that my y is negative because none of those points drop below. My problem is if I try to graph it in the window that I'm looking at on my screen, that looks really yucky. It's really hard to see. It looks like we might want to go all the way up to 20 if I read on. So let's see if, I don't know, well, x equals 20. I guess that's not going to work out so well for me. So maybe we don't want to look at that just yet. Maybe we might need to use our table for that one. Maybe we want to try 5, see what happens. That's a little bit nicer to see. Maybe we want to do that. At least we could use, I don't know, we could use that for A, B, and C. Okay, so let's make our tables of values here. And I'm going to graph, let's say, what is it, 1, 2, 3, 4, 5. That's good. I can actually squeeze that all in there. Okay, so let's look at our table for my x squared. I think I have some space over here, so I'll do f, or x and f of x right over here. So x, 0, 1, 2, 3, 4, 5. And 0 is 0, 1, 4, 9, 16, 25. And my g of x function, let's do the same. So x and g of x. I'll do this in a different color. I think I have enough space if I do that. So 0, 1, 2, 3, 4, 5. You know, these are the basic parent functions, so some of you might say, oh, I remember what these are. If you don't, we have our technology to help us generate the points. Okay, so here's my two table of values. It looks like I need to go all the way up to 32. What if I count by 2s? Will that get me there? Sure does. So let's go ahead and just... Actually, no, I'm not I wanted to count by 2s, not by 1s. So each one of these grid lines will be 2. So that'll be 2, 4, 6, 8, 10, 2, 4, 6, 8, 20, 2, 4, 6, 8, 30, and 2, 4, 6, 8, 40. Okay. I'm going to graph f of x first. So I have to graph the points 0, 0, 1, 1, 2, 4. Just be careful of your scale. 3, 9 will fall there. 4, 16. So 12, 14, 16 falls there. And then lastly 5, 25. So here's my 20, 2, 4, 5. Okay. And I'm going to connect these with a curve. This is only part of my parabola. Label it, and don't forget that we should be drawing an arrow on the end of the line. All right, go ahead and graph your g of x function. Okay, so there is my g of x function. Notice how it dips a little bit below the f of x one over this interval from 2 to 4. Okay, so what we're going to do here, maybe I'll use my, I don't know, purple pen, maybe? It says justify and identify which function, f of x or g of x, has a greater value when x is equal to 0. Okay, so when x is equal to 0, we can see that f of x is equal to 0. And actually, I should do f of 0 equals 0. So g of 0, this is just a point, 0, 1. We can also see this in our table of values. So let's circle g of 0. Let's do the same thing with x is equal to 2. Some of you might say, oh, I like it better in the table. So if I wanted to find f of 2 is 4. And hey, g of 2 is also 4. So they are the same. Let's write that down. All right, x is equal to 3. You guys getting the hang of this? F of 3 is equal to, 9, where g of 3 is equal to 8. So f of 3 is bigger. How about x is equal to 20? F of 20, that's not in my table. Neither is g of 20. But where can I find it? You're right, the calculator. So we are looking for the x value of 20. And oh my goodness, f of 20 is 400, where g of 20 is, what is that, 1048, 8576. So that's over 1,000,000. So I think it's safe to say that g of 20 is bigger. All right, heading on to question 3. Alicia has invented a new app for smartphones, and 2 companies are interested in purchasing for a 2-year contract. So cool. All right, company A is offering her $10,000 for the first month and will increase the amount each month by $5,000, where company B offers $500 for the first month and will double their payment every month from the previous month. And it says monthly payments are made at the end of every month. For which monthly payment will company B's payment first exceed company A's payment? All right. Well, maybe we want to start off by modeling this function. So we're going to have x and y, where x is our months. So in the first month, I'm just going to leave a little bit of space because they never talked to us about like the 0th month, if I can even call it that. But company A, I'll make this A. So they first give her $10,000. Oh my gosh, that's so much. Then in the second month, how much do they give her? They give her $5,000. So she'll actually have $15,000 in the second month. And in the third month, add another $5,000. We'll give her $20,000. Whoa. Okay. So technically, if I just follow this pattern backwards, in my month 0, wouldn't that just be 5,000? Okay, I might need that. I might not. Let's talk about company B. Let's do the same thing. So with company B, again, I'm going to leave that 0 month there. Then in the first month, she only gets $500 as opposed to $10,000. Well, this kind of doesn't look like a great plan. What happens in the next month? The payment will double? Okay, so double 500, isn't that 1,000? And then it looks like we just need to keep doubling that, so 3 months would be 2,000. Then 4 months would be 4,000. We could keep going, but I think we have the pattern here. So if we work backwards, it looks like we're multiplying. by 2, aren't we? So if I wanted to go backwards, couldn't I just divide by 2? So 500 cut in half would be 250. All right, so what it's asking is for which monthly payment will company B's payment first exceed company A? I mean, gosh, that's right now we're at 4,000 compared to 20,000. That's not even the 4th month here. That was only the 3rd month. So I'm having a hard time figuring this out. Maybe we need to come up with some algebra to help support or figure out what's going on here. So let's say company A would equal, well, how do we start? How could we model this? We started at 5,000, right? And then we kept adding what every single time? Didn't we just add 5,000 every single time? Okay. And then company B, we started at 250, but then we kept multiplying that by 2 over and over and over again. So that's how I would have to model it, 2 to the x power. So maybe we need to graph these. Well, when I first graphed them, clearly the window is terrible. So let me just see if I can pull that. That's still not helping me out at all. I mean, I have to go all the way. My y-intercept here is like 5,000. So maybe we want to say, I don't know, these values are getting pretty high. So maybe we want to try like 100,000. I mean, that's going crazy. Let's see if that helps. Ooh, that worked out to be a lot nicer. All right, okay, I'm seeing what's happening here. So, oh, isn't that weird? My 2 colors are different. I didn't even do that on purpose. So my green function over on my screen is actually my pink one on the screen. And then my pink function over here, or I don't know, whatever it is, it's backwards colors. So be careful. All right, so I'm looking at this, and my B function, which is the green one here, is lower for a while, and then at this crossing point, this point of intersection, what is that point of intersection? Let's figure it out. The intersection is 7.3, 4.2 e to the 4th power. Whoa, that's a really high number. That's like 4.2 e to the 4th power. So what is that? 4.2 e to the 4, so that would be 4.2 times 10 to the 4th power, which means I move my decimal over 1, 2, 3, 4 spaces. So that is really 42000. That's 42,000. Did I do that right? Yep. Okay, so that's telling me that it says for which monthly payment will company B's payment first exceed company A's payment. I'm going to bring this down here. I'm running out of space. So we know that the break-even point would be at 7.3, month 7.3, 42,000. So what month? So let's put break-even. So the break-even point would be right after the 7th month. So really, what month payment will be higher than A? That would have to be month 8. And if we just check out our table of values here, let's look at month 8. So it looks like, yeah, these numbers in my company A are still higher, still higher, still higher. Oop, there's the switch. Look at that. So we found between month 7 and 8, so we would say month 8 would first exceed company A. All right, we're going to save, it looks like, what, 4 and 5 for class time.